In this video we're looking at volume still. This time we're looking at the volume of pyramids. Now here's a pyramid here, like like the pyramids in Egypt. As you can see, it's got a square base and it comes up to a point in the middle. Now pyramids are related to prisms. So if you can find the volume of a prism, you can find the volume of a pyramid very, very easily. Now I'll just quickly look at the volume of this prism first, and then we'll talk more about this pyramid. So let's say that the shape here was 3 by 3, so they're the same, but the height was, say, 5. So 5 centimeters by 3 centimeters by 3 centimeters. Now to find the volume of that, you would do the area of the cross section times the height. So quickly working through it, we'd have 3 times 3 for the area of the cross section times the height. So that's 9 times 5, which is equal to 45. Let's say it's centimeters, so that's centimeters cubed. Now that's how to find the volume of a prism. Now let's look at our pyramid. Now you can actually, it's pretty amazing, and we can look at a video that'll show that it's true. But if a pyramid has the same dimensions as a prism, that is, if its base is the same, so 3 by 3, and its perpendicular height is the same, the volume of the pyramid will be 1/3 the volume of the prism. So if you imagine you were trying to send this prism in the post, you wouldn't just wrap it up and send it if you were trying to send this pyramid in the post, you wouldn't just wrap it up and send it. You'd put it in this box. So the volume of a pyramid is equal to 1/3 of the box that it would fit into. So the way that we can create our formula now is the area of, we won't call it the cross section because that's a bit misleading. A cross section is the same all the way through. So we'll say area of the base times the height, and then divide the whole thing by 3. So in this case, we have the area of the base, which is 3 times 3, times the height, which is 5, and then we divide the whole thing by 3. Now 3 times 3 times 5 is 45, same as the area of our prism, and then we divide the whole thing by 3. So we get 15 centimeters cubed. So the takeaway here is that the volume of a pyramid is equal to 1/3 of the box that it would fit into, of the prism that it would fit into. We might just look at one more of these. Now this time we're looking at a special type of pyramid. It's a cone. Now if you wanted to find the area of this cone, it's really quite simple. You find the area of the box that you would send this in the post with. So if you were going to send a cone in the box, you wouldn't just wrap it in the post. You wouldn't just wrap it up as it is. You'd put it into a cylindrical or a cylinder box, something that looked a bit like this. Okay, so here's our cylindrical box. Now, obviously, it's going to have the same dimensions as our cone here. So it's going to have 5 centimeters from there to there, and it's going to have a height of 10 centimeters. Now, if we find the volume of this, remember volume equals the area of the cross section times the height. Now the area of the cross section is pi r squared because it's a circle times the height. So that's going to be pi times 5 squared times height, which is 10. Now you can do that on your calculator really quick. That'll give us 785.40. That's close enough. And finally, to find the volume of a cone, we do pretty much the same thing, except we only need to find a volume 1/3 of that. make sure you put your units in, centimeters cubed. Okay, so the volume of a cone is going to be equal to the area of the base times the height divided by 3. Okay, so it's a third of whatever that box would be. So the area of the base, again, is pi r squared times the height, which is there, and then divide the whole thing by 3 again. So we get pi times 5 squared times 10 divided by 3. Now that's going to equal whatever that was divided by 3. So let's try that out. 261.80. Okay, so whether you're doing a cone like this or a pyramid like this, the rule stays the same. The area of a pyramid or a cone is equal to 1/3 divided by 3 of the box that it would fit into. Now you can learn these formulas, or you can learn the underlying principle behind the fact that a pyramid is equal to 1/3 of the box that it fits into.